is where I left off in the last example. What I am going to do is I'm going to re-explain what I was doing so we can remember what was taking place in the last video. In the last video, what I was doing was seeing whether or not this was a linear function. And so I looked at all my x values, and I noticed that every time I changed my x value, it went up by 4. Now I was looking at my y values and seeing if it had a constant change as well. So from negative 3 to 0, that would be a plus 3. 0 plus 3 gives me 3. 3 plus 3 gives me 6. And 6 plus 3 gives me 9. So there is a constant change in x as well as a constant change in y. So it is linear. Linear. Because a constant change in x corresponds to a constant change in y. I will not write that again. I will just state it. So we're going to go through a couple more examples to see whether or not it satisfies a linear function. So this time, maybe I will highlight all of my x values so that you know that I'm just looking at those x values. And what I'm doing is seeing if there's that constant change between each one of these. So if I look, how do I get from negative 4 to negative 2? Well, I would add 2. From negative 2 to 0, I would add 2. From 0 to 2, I would add 2. And from 2 to 4, I would add 2. Looking then at my y's, I would say, how do I get from 13 to 1? Well, I would subtract 12. How do I get from 1 to negative 3? I would subtract 4. How would I get from negative 3 to 1? I would add 4. I can already tell there's not a constant change in y that corresponds with the constant change. There's not a constant change in the y value that corresponds to the constant change in the x value. So this is not linear. There is no constant change in the y values. In this next example, I am going to tell whether or not the set of ordered pairs is a linear function. I'll do it in the same way where I'm going to be highlighting those x values. I think it makes them stand out just a little bit more. So if I look just at these x values, notice again it's going up by 2, up by 2, up by 2. 9 plus 2 is 11. And then I'll do the same thing with my y values. This time 5 minus 1 is 4. 4 minus 1 is 3. 3 minus 1 is 2. And 2 minus 1 is 1. So this is, yes, it is a linear function. Reason being is that there's a constant change in x that corresponds with a constant change in y. Looking at this, there's a lot of information on this page. What I really want you to take out of this slide is that there is a form called a standard form. So another way to determine whether a function is linear is to look at its equation. A function is linear if it's described by the linear equation. A linear equation is any form or any equation that can be written in standard form below. This is considered to be a linear equation. So I've got a number like 3. 3 could be A, 5 could be B, C could be negative 2. Okay, so that's what it means when A, B, and C are real numbers. A and B cannot both be 0. Other things that happen in the standard form is that x and y have exponents of 1, and x and y are not multiplied together. X and y do not appear in denominators, so no variables in the bottom of fractions, and they're not in exponents or underneath square roots. We'll talk about this again here on the next video.